This is the lecture video for Forensic Science, Chapter 5, Physical Evidence. So this chapter will cover types of evidence, the significance of evidence, evidence databases, and finally, forensic palynology. The purpose of examining physical evidence by a forensic scientist is usually for identification of physical and identification of the object and physical and chemical identity. So a specific substance found maybe is a white powder. Could it be a controlled substance or not? What's in it? Blood samples or toxicology. Explosive residues, species identification, and or type of biological material needs to all be identified. Comparison evidence is also required by forensic scientists. This you need a reference sample, like we talked in um, chapter 4. So examples for comparison analysis is fingerprint analysis, which compares the evidence patterns to a reference sample collected directly from the subject and or databases. Bullet comparison is a cartridge casing found at a crime scene consistent with being fired from a suspect's gun. So we have to find the gun or have it in a database, the bullet in the database. A fracture match. Did duct tape found on victim's wrists originate from a roll found in a glove box of a suspect's car? So you have to compare the two things to determine if it is, likely to be a match. So again, we have chemical and physical identity and a comparison. The objective of an identification is to determine the physical or chemical identity of a material. Um, and in order to do that, we must validate first the test method that we're going to use. So, validation means the process to evaluate a test procedure to determine that it is reliable and gives the correct answer. So there's developmental validation, which validates the actual test to see, can this new test procedure tell us what we want it to? What kind of testing controls might be needed? And there's a lot of new DNA tests that are coming on down the pike. And then after you do your developmental validation, you have to do an internal validation, which verifies that the test is reliable and reproducible in a particular lab. So, how is validation performed? Testing of known samples and standards are done in order to ensure that there are no false negatives. Testing of other related substances are done in order to ensure that there are no false positives. So, for example, if I have a specific drug that I want to test, I'll test that drug over and over and over again just to make sure that, every time I test it, my test says, yes, it is that particular drug. And then I'll get other drugs or other chemicals that are similar and test those just to make sure that my test doesn't say, "Oh, yeah, that thing that I know is not actually the drug." The test might say it's the drug, which will make it a false positive. Sensitivity, optimization, and reproducibility and repeatability of the test are very important. Um, can there be other substances that interfere with my test? All those questions have to be answered before you can use the test method to identify substances. It's helpful to understand what contaminants might routinely accompany the evidence and do they interfere with the test method or procedure. So, for example, in cocaine, there's also included in cocaine oftentimes sucrose, lactose, or talc, just to, kind of cut the cocaine, dilute the cocaine a bit. After the validation study is complete, the forensic lab adopts a standard operating procedure to confirm the identity of a substance so that they do the test the same way every time. You don't want to introduce error or mistakes just because you're doing it differently. So you do your process A, B, and C, and if any of them fail, then your test is inconclusive. Um, okay, so another procedure that you might do rather than a chemical test is a comparison test. So what a comparison does, it compares a combination of selected properties between your reference, your unknown, and your exemplar. So your reference is the exemplar. So you know what that is. And the sample is your unknown. That might be from the crime scene or whatever. And generally, you're looking for specific minutiae to match. So very specific characteristics should match. So in a bullet comparison, it might be the firing pin marks, or the ejector markings, or the magazine markings have to exactly match. For a fingerprint situation, there are all these like ridges and whorls and loops that need to match. And for fingerprint, there's usually a set number of features that must match for it to be valid. I want to say it's in the 13 point range, 10 to 13 point range. I'd have to look that up. I'm not totally sure, but it's a certain amount to give a pretty good um, reliability. So the Brandon Mayfield is a man who was falsely accused of a crime. They actually, his fingerprint, this is from the crime scene. So Mayfield's fingerprint, which he was in the military, so they had his fingerprints, um, matched in some of the minutiae from a crime scene fingerprint, but so did like 19 other people's. And they just kind of focused right on Mayfield. So he was later exonerated from that crime because they didn't match enough features. So, like we said, there's individual characteristics, which properties of evidence can be attributed to a specific source. So DNA is pretty much an individual characteristic, I guess, mostly, right? Your DNA and an identical twin will have the same DNA, but the probability that your DNA would match another person's DNA, if you have enough sites that you're looking at the DNA, is like 1 in, a trillion or something like that. And that makes it pretty much individual. Class characteristics, though, are properties of evidence that can be associated only with a group and not a single source. So, for example, what brand of shoe do you wear? Well, a lot of people wear that brand of shoe, or maybe even the style of shoe of that brand. It's still quite a few people. Or say your blood type. A blood type could be a class characteristic. So, what percent of the population has type O blood? Well, pretty high. So class characteristics narrow it down, but can't identify specific individual. Individual characteristics do. Classifying characteristics. Talking about class versus individual even more. So evidence associated with only with a group is said to have class characteristics. Evidence that can be associated to a common source with an extremely high degree of probability is said to possess individual characteristics. So class characters, for example, how many layers are present in the paint? Here's a paint chip. The color of the layers individualize a paint chip to a single car. I would say probably not, right? All the cars that get painted in the same way would probably have very similar paint chips, unless you have a certain individual variation to it. The chemical fingerprint of each layer. Uh, I suppose maybe if it's a custom job, but other than that, then no, it'd be a class characteristic. So an example of how class characteristics can like get narrow and narrow until it's pretty much an individual characteristic. So for a sneaker eliminates other types of shoes. So if you have a footprint, a shoe print, or an actual shoe, sneaker shoe, you can say, okay, well, people who wear, dress shoes wouldn't be in that group. Then you have mold defects in the mold. So it eliminates all Air Max Tavas that do not share the same mold defect. So when they're making the sneaker, the sole of the sneaker, there might be a slight defect in making the sneaker. And that could narrow down that type of shoe even more. Then you have use defects, which are random, right? They're not uniform, which are just cuts, indentation, wear marks, scrapes, and scuffs that happen when you actually use or wear a sneaker. And then abuse defects, which are also random, and these are exceptional wear and tear, such as on a motorcyclist's habit of dragging his feet on the ground while coasting to a stop light. So these are different examples of how you can start to narrow down a class characteristic to maybe get to where it's pretty close to an individual characteristic. As we go here, individual characteristics. Examples of individual characteristics are minutiae and friction ridge analysis, random striation marks on bullets or tool marks, irregular or random wear patterns in tire or footwear impressions, like we were talking about the sneaker before, handwriting characteristics, or irregular edges of broken objects. So this gives you, I think this is a sneaker impression, and the arrows show here's some sort of a defect right in that exact spot of the sneaker. And in this one, there's a defect right in that exact spot of the sneaker. And where this arrow is, if you look really closely, there's a teeny weeny white spot there. It's a defect. And in this picture, it's a teeny weeny black spot there. It's a defect. So these two, the probability that another sneaker of this exact type of shoe would have a divot there and a little mark there in the same exact spot is very, very low. So therefore, you can with a pretty high confidence say that this shoe print and that shoe are a match, right? So how does one conclude the source of an item by matching individual characteristics like footprints, tire tracks, handwriting, fingerprints, shell casing? It's basically done by analyst training and experience. So, you get training on what kind of things to look for, and experience is just practice doing it, looking for it. So here's an example, I think, where they're trying to match a tread mark of a tire to an impression there. The forensic scientist must be prepared to render a conclusion or opinion with respect to the origins of that sample. So basically, is it excluded? So it did not come from whatever the reference material is, reference sample is, or did it? And what's the probability of the two that they are a match? In other words, they came from the same origin. So with many analytical processes, exact probability is impossible to define. But so you may only be able to tell the jury that is more likely a match. So there's this case, U.S. versus Glenn, is the history of reasonable degree of scientific certainty. So a detective Valenti testified that the ballistics examiner matched the defendant's gun to a reasonable degree of ballistic certainty. The court interceded, stating he seriously misled the jury as to the nature of the expertise involved. In Glenn, the expert was limited to testifying in terms of more likely than not, but nothing more. So the wording is very specific there. All right, so the value of class evidence. We've talked about class evidence, right? It's like a class, a group, it narrows it down to a group or a class of, objects, right? So when one is dealing with more than one type of class evidence, the collective presence can lead to an extremely high certainty that they originated from the same source. Okay, so a muddy footprint pattern, right, at a crime scene that's consistent with the suspect's sneakers, which maybe are also muddy. So I can say, okay, the suspect has a shoe that looks like this kind of footprint, right? But so probably doesn't a lot of other people, right? Have the same type of sneaker. But if the suspect sneaker also contains fibers that were found in the carpeting in the suspect's car. Oh, no, I'm sorry. The footprint here, maybe you might find some tiny fibers in this impression that was also the same type of fibers, same like polyvinyl chloride fibers or whatever in the suspect's car. Well, there's a second piece of information that connects this footprint to a particular person, but it's still not conclusive because how many people drive that car? Now, let's say the tires of that car, of the suspect's car, has tread patterns that are consistent with tire tread impressions in the mud at the crime scene. Well, there's another coincidence or another class evidence. And then also near which oil and cigarette butts consistent with the brand of motor oil leaking out of the suspect's car engine and the brand of cigarettes that the suspect smokes. So there are 4 different things, each individual one taken by itself, you can't say with a high degree of probability that the suspect was at the crime scene. But when you take them all 4 together, it seems like it's a pretty good chance that that could happen. So there's a thing called the product rule. It's really probability. So it's a formula for determining how frequently a certain combination of characteristics occurs in a population. So to do that, you determine the probability of each characteristic occurring separately and multiply together the frequencies of all the characteristics. So, I'm making up the numbers totally here, but like 1 in 100 people have that kind of shoe, and 1 in, I don't know, 1,000 people have that kind of car, with the carpet, and so on and so forth. You put some number, you add them all together or multiply them all together, and that will give you the probability that that person is the actual person that was at the crime scene. Okay, so just in summary, the value of class physical evidence lies in its ability to corroborate events with data that is free of human error and bias. As the number of objects linking an individual to a crime scene increases, so does the likelihood that the individual is involved, and that is the product rule that we talked about. And finally, a person may be exonerated or excluded from suspicion if physical evidence is found to be different from a standard or reference sample. All right. Now we're going to change to forensic databases. I think I actually talk about a 5th one in here too, but there's the APHIS, which is a fingerprint database, CODIS, which is the DNA database, NIBIN, which is ballistics, and PDQ, which is paint. And at some point, you might want to take notes of these because these are the types of things you need to know, and it's easy to get them mixed up, like which one is for which. So the APHIS or IFIS database is the Integrated Automated Fingerprint Identification System, is a national fingerprint and criminal history system maintained by the FBI. It was launched in July of 1999 and contains 100 million subjects. The It processes over 63,000 submissions daily. It's a repository of criminal history, fingerprints, and subject photos. Positive identification is based on fingerprint submission. Oh, here it is. A 10 print and latents. Oh, it doesn't say how many points. 10 print, meaning, 10 fingers, and latents. The tentative ID of subjects based on descriptive information, which is name, date of birth, body markings, etc. CODIS is the DNA database, and it stands for Combined DNA Index System. It enables federal, state, and local crime laboratories to electronically exchange and compare DNA profiles. It was launched in 1998 as of July 2016, has over 12 million convicted offender profiles. Wow. 2 million arrestees and 720,000 crime scene profiles. I think they're using a different system a little bit now, different testing system than that, but all right. And then we have the National Integrated Ballistics Information Network, or NIBIN, which is the firearm labs acquire, digitize, and compare markings on casings and stuff like that, and bullets. NIBIN started in 1999. There are 2.8 million samples and 34,000 hits have been recorded. Then you have the PDQ, the International Forensic Automotive Paint Data Query, PDQ, which is run by the Royal Canadian Mounted Police. And this contains chemical and color information of automotive paints, 20,000 samples of paint systems, and 74,000 individual paint layers used on most domestic and foreign vehicles sold in North America and Australasia. So that's the PDQ database. And this is the one that wasn't on that first slide, the SICAR, Shoe Print Image Capture and Retrieval System. And it has two reference collections, the Soulmate, which has 34,000 records and is updated quarterly, of images of sole, uppers, pattern features, codes to facilitate searching and matching. And TreadMate, our tire tread patterns, currently contains over 8,500 records. The manufacturer includes the manufacturer, reference samples, date of release of the product, image of the tire, pattern feature codes to facilitate searching and matching. All right, so just to give a little bit more interest, hopefully, here's a NIBIN case. So in May of 2003 in Minnesota, a man jumps from in front of a car and shoots Emily Beaver 4 times. He steals her car and uses it the next day in an armored car heist in Hudson, Wisconsin. The car was found burned out in Hudson. And 5 years later, the police arrest a man for the unlawful possession of a firearm. And, so he had a firearm, and that firearm was linked back to Emily Beavers and the armored car heist, right? Using the NIBIN system. Okay, collection of physical evidence must be material, meaning detectable, collectible, examinable, comparable, and analyzable by human senses alone. So you can look at, see, smell, and touch it, or by enhancement methods like optical, physical, chemical, etc., and associated in some way with a crime. And physical evidence should link the perpetrator to a crime. It may be obvious by just looking around, or it may be latent, which means you can't see it by the naked eye, requiring the knowledge, skills, and abilities to locate and collect it. Okay, so let's do a check for understanding. For each of the following pieces of evidence, indicate whether the item is more likely to possess class or individual characteristics and explain your answers. So, an impression from a new automobile tire, a fingerprint, a spent bullet cartridge, a mass produced synthetic fiber, pieces of shredded document, commercial potting soil, skin and hair scrapings, fragments of a multi layer custom automobile paint. Oh, custom. I didn't read that. So here's what I wrote is impression from a new automobile tire. That would definitely be class because it wouldn't have any individual gouges or defects that would make you allowed to do an individual. A fingerprint, individual. Spent bullet cartridge, I say it depends. If you have enough, if it's well enough preserved and there are some specific defects on it, it could be an individual. Otherwise, it might just be class. Mass produced synthetic fiber is definitely just class. Pieces of shredded document, it depends, right? If you have some identifying either chemical like a pen marking or something on there, you might be able to say individual. Otherwise, it'd be just class. Commercial potting soil, class. Skin and hair scrapings, probably individual. And fragments of a multi-layer custom automobile paint. Okay, so when I read this, I didn't see custom. If it's custom, like individual custom, then that would be individual. If it's just automobile paint, then it's probably just class. Which of the forensic databases described in the text contain information that relates primarily to evidence exhibiting class characteristics? Class characteristics. The PDQ and SICAR, class characteristics. Which ones contain information that relates primarily to evidence exhibiting individual characteristics? CODIS, APHIS, and NIBIN. So the PDQ and the SICAR, they have a lot of like paint samples from the manufacturer and tread and shoe imprints from the manufacturers, right? So these would be class. Whereas CODIS, DNA, APHIS is fingerprints, NIBIN as bullets. These guys have like the individual defects from individual people or in this case, guns, so that you can identify the specific gun or person that has the DNA or fingerprint. So those would be individual. All right. The last section of this chapter is forensics palynology, which is about pollen and how that can be some really good low card, touch evidence, physical evidence there. It's a very specialized forensic science. And rather than go through it myself, I have actually two videos here. So this first video, it's there's no volume to it. It's just like text, but it's a nice overview. And they talk about 4 different cases at the end of the video, starting at 2 minutes. So this video is only about 3 minutes long. It's very short, but I thought it was a nice overview. So what I'd like you guys to do is watch this, on your own, not through this video lecture. And then the last video has a little bit more of the science behind forensics palynology. And so I thought that was a good video for you to watch too. This one I think is about 11 or 12 minutes. So please do take a look at both of those videos at the end of this.